This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Hey. Hey, Jacek, can we start earlier? Like in 7 minutes. So sorry for just a bit very fast clicking just a few seconds before. I didn't set up everything as I planned, but I'm sure that it will go well. Okay, the testing code is simple because we have just 2 directories to select. We can either put a test in integration test or in test. One thing that I have noticed, that my presentation is bottom heavy. So folks from behind might have problems. And the second thing that I've noticed is that I've clicked too fast. I'm doing architecture in Circle K. Right now I'm charging electric cars. I'm doing the system that supports charging electric cars. There's a lot of fun in there because cars are pretty intelligent. And we know where you are in your electric car. Because you accepted terms and conditions. Yeah, and I'm a trainer in Bottega. There was Sławek and Kuba from Bottega as well. I'm teaching their testing, left shift testing, or shift left testing, whatever you prefer. Testing strategy, contract testing, and the architecture, modularization plus domain-driven design. And the funny thing, I have a lot of fun from watching this structure of integration test and test, because this is how our build tools has forced us, gave us just those 2 options. And we know that integration test is the one that starts Spring Framework, right? So it's not about discussing the scope, what is the scope of the integration test, or what is the or it is just thinking, do I need to start Spring to test it? Need, or do I have to? Am I forced? Because my app is constructed in a way that I have to start Spring to test my business process. And we are not stuck only with this, because we have almighty end-to-end tests. We can test everything there. Right? We can click through any UI, 7 hops deep in the system, detect that it is not accepting the name that has emojis. Those are the options that we have, and we are writing a lot of tests. So it's not that we are writing more of the test code than the production code. Actually, for each line of the production code, we have 1.5 lines of test code. And this is when the tests are well crafted, not duplicated, and they give a coverage, because oftentimes we have up to 2 lines of test code. We are testing it. We are copying it from one test. We are copying and creating another, and bam, 10 lines to our statistics. But it is still taking us time. So they are interviewing us on how do you test your code? They are doing conference speeches on testing. So testing is a thing. On the other hand, somehow we ourselves are not really treating it sometimes as an important part of our job. There is an explanation that, I need 3 more days for testing. I can implement it for you in 2 days, but give me 3 more days, so I will also test it automatically, and I will have regression and stuff like that. Because testing is perceived as something that slows the delivery down, which is that without tests, we can start very fast, like 100 features per sprint, for example. But without tests, the speed is decreasing, because we are stuck with bug fixing, not implementing features, we are bug fixing. Whereas with tests, we have to do the setup, we have to implement the fixtures, use test containers, use wiremock, use anything. And so we start slower, right? We won't be at 100, we'll be at 60 features per sprint. But this will be more predictable and more secure. So it might be slower when we look from the perspective of the current sprint, but from the whole product lifetime, it won't be. Okay, so with those 3 levels of tests, we also end up very often with units that are, no unit is the same than to other units, right? Because one unit is on class, one is on method, one is per module, one is testing mocks, which has special place in my heart, actually. So if we don't have a clear definition of unit, we are unable to have clear definition of what integration is then, because integration is meant to integrate to units. It's one of the definitions. We are clear in defining what end-to-end is, because it's everything. So it's easy to define. And no surprise, because often our structure, our code, production code, looks like that. We have APIs, we have services, and infrastructure. And this is the simple part when it comes to APIs and infra. Because we have controllers, they are exposing API or listening to events or handling commands. And we have infrastructure, so connecting to the database and external services. But seems that we are doing more complex things in a services layer. There is complexity in there, and the unit with unclear definition doesn't fit there. I'm calling it a Duplo unit and Duplo integration. And I'm calling myself this guy who would like to advance a bit. I'm no longer interested in Duplo. I want to play Lego. Turns out that before Duplo, there is Baby and Quattro, so I'm already over that. But I'm still on Duplo. And here's 4 plus. 4 plus for Lego, so sounds like a perfect senior. To me, this thing is a Duplo thing. So what could be a Lego thing so that we can advance, make a step ahead? This thing, right? So this granularity, I need more granularity. There's a lot of, in this slide, I'm going to explain it later, briefly again. But this is what I would call Lego. So I can construct the same buildings or different buildings. I can construct the same buildings with Lego that I can with Duplo, which is not true other way around, right? Because Duplo are big and clumsy, and it's harder to decompose. Like Duplo is impossible to decompose, but Lego, it's easier to compose, right? So I prefer to have smaller chunks to merge them, rather than trying to split them. So we're talking about, I'm talking about a strategy, which has 2 goals. First, to guarantee the coverage, I mean coverage up and duplication down. We don't want to have a duplication. We need to have as few code in test as possible, so avoiding duplication, not testing the same thing twice. But we need to guarantee the coverage. So this give the security. Those GIFs are so annoying. I can't focus when they are blinking. I can't focus. So I hope that you're happy now that they are no longer on the slide. Okay, so Lego strategy. It's about the controllers. It's about the testing each building block of our application. Testing it with dedicated set of tests. And this is where my setup right now might give me a bit problems, but I hope it's gonna work. Yes, perfect. So I'm gonna switch. Okay, so this is my API test. I have some state in a database. Here I'm persisting some concert in a database, concert configuration, and I'm calling my test HTTP client to discount the price for this concert. So purely HTTP thing, and I'm asserting the result. I'm asserting that price in the response has a single price of 90. Asserting the price means basically that the status code is okay, and digging into the JSON, that JSON has this value that I was expecting. Okay, here's the slide. So I'm verifying the output. I'm doing the output verification. I don't care how it was built inside. I'm just setting the state. Concert has to be there to discount it. but I'm verifying only the output. One thing here is that you can ask questions, and I'll see it here. There will be also a slot for questions after I finish talking. Yeah, so the next level, after we have this request received by our controller, we are doing the validation test. I mean, yes, the field in JSON, maybe we've parsed it on a controller or on API levels, but Lego validation tests are about checking whether the value within the field is valid from the business perspective. I mean, if the integer is age has to be above 0. It cannot be below 0. This is the difference between the semantical verification versus syntactical. Syntax is okay because it is a number, but semantically, age has to be above 0. So very often we're meeting things like data tests that are asserting that some input produces some output. And here are the different cases for that. So again, this is output verification. I'm sending output to the method and verifying, sending input and verifying the output. For the process test, if data is validated, I go into the process. So I'm processing it, I'm sending it to database, to some queues, sending emails, sending pushes, saving the database. So process test is implemented on service, right? So constant service should create concert. And as a result, I need to make sure that this is right, correct, and this is persisted in my repository. So this is one step of a process. Other step is that I'm publishing event. Other is that I'm changing some values. So this is one of the steps of my process, business process. So if business explains when somebody creates a concert, we need to send a notification, email, SMS, notify, change this and this. This is the business process. And we might have interaction verification. This is most often the case because we are interacting with with a database. And because we are interacting with a database, we're also doing the state verification. So the state in a database has to be correct. And this is the part of the process. Then I have domain tests, which is guarding domain rules. Again, I'm doing output verification in here because the domain is agnostic from the storage, from the integrations. It should just do the domain logic. And so what I can assert is if I give you the input, I'm expecting the output. That's the assertion that I have. Domain services, here I have service, not a test, to show you that, well, those are pure functions. So I'm checking, again, verifying only the output. As you see, the output verification is the most often, the most demanded because, well, it doesn't have, it is very black box testing. So I'm not limiting myself from refactoring safely, securely, without excessive changes, because I don't know how it is implemented inside. If I don't know, I can freely change the implementation inside without affecting the output. So verification on output is secure. Yeah, and I have the input. I should get the output, and this is what I would assert in tests. There's also one thing that we are doing. If we are persisting a concert in a database, let's say with the same value, there might be a unique constraint on a database that would prevent me from storing this value. So those are data consistency tests. And very often we are not naming it explicitly, but we do test whether the unique constraint is not affecting how we are saving, how we are persisting data. Yeah, so it's data consistency. It's like in the business process, we're working on a single concert, but in a database, we have a lot of them, and they have to be consistent across each another. And state verification, but I wanted to focus on web clients and on dependency test. So I want to make sure that when I'm calling my HTTP client and calling apply percentage discount, which is a method below there is a rest assured that is calling external API, I want to make sure that this result is of some value. But here the trick is that I also have fake pricing client, which is returning hard-coded results. And what I'm doing in this test, I'm comparing whether the fake result is exactly the same as the real result. Because lots of my tests rely on fast fake pricing client. It's in-memory hard-coded implementation. And I have one test that is confirming that real results are the same as fake. So all the tests that rely on fake are more credible. So here I'm checking whether the interaction happened, right? The interaction of my web client with external API, which is most often WireMock, and end-to-end tests. No, anything more about end-to-end tests. We'll be bashing them later. Okay, so when request comes, we're doing the API test. In most of the cases, we are setting the status code and the fields in the JSON. We are doing the validation when we are checking if invalid string returns invalid string error. We have process test where quite often we see that we have mocks, that something should happen, read model should be updated, database should be updated, and so on. And the domain test, where in most of the things we are asserting our domain objects. So I'm working on concerts. I'm checking whether the category was properly assigned when initiating the concert. And the dependency test, which are checking whether the event was published on a service bus. So we are checking our dependencies state that were set on the external dependency. Most characteristic for data consistency test is that we are saving something to the repository and checking whether this SQL that we wrote or Spring data that we crafted is fine. So most popular things, what I'm heading to is to verify the output, to have the black box testing. Sometimes I'm checking the interactions because I'm in my business process. So process is interacting with different external components, which can be mocked. In domain, in most of the cases, we are not using mocks. We are using new, so real implementation instead of mocks. And in lower layers like infra, we are using in-memory repos or test containers or ideas as such. Okay. So how does the Lego pyramid look like? It has to be the most boring Lego set ever. Building all those trees, it has to be a nightmare. But instead of unit test, I'm having domain test and validation test. So two types. Like we've had different types of unit. I'm naming them so that we can talk about that we are talking. If we are talking about domain test, we know what we mean. Those are units, and those are tests that are integrating Unix. So process is using several domains that require validated data. And dependency test is a different type of integration because we are integrating there with external systems, or database is a kind of external systems, whether this is an external API or a database, it is external still. And API test. On the top, next to the pyramid, we have different pyramids, different systems, and this is where end-to-end tests are. No, nothing more about end-to-end tests. And at the edge, we might have contract tests as well. But it's not that simple that every system, every component in my system is the same. They are much different. I'm pretty good on time, fine. they're much different. We might have different complexity here in my big system. So yeah, let's say that if we analyze the Lego service, DDD service, others are completely different. So we will be composing stuff. It is magic that I have discovered that Lego bricks can be connected with Duplo bricks. And this is what we'll be doing right now, because sometimes we need very specialized scope of test. We have very specialized thing to test, but sometimes we are unable to write such a small test. We need to head back to the something bigger. So, for example, very often, this is how we are constructing our applications. We don't have a pure DDD domain logic inside, separated clearly. We have a bunch of services. So in this case, yes, we do validation here, we have process here and domain, but they are not separate. So we are not separating the test, and we're writing a kind of module tests and end-to-end test as well, which is very similar to Duplo unit. Right? We have a big thing, but with clearer definition of where are we heading. We are heading not to unit per class, unit per method, per module. We are heading to validation test, process tests, and domain tests. So it gives us a bit more direction. And this is still a pyramid, because the complexity in the system is the same. We have complex domain logic, but we are not able to test it in isolation. So we have module tests that are kind of integration, kind of unit. But still, the tricky part is that they can be executed without starting the framework. Later on that. Okay, and the Lego strategy modified in a different way is the simple strategy. We call it a CRUD, or a node, how Brian and Marian were calling it. In CRUD, we don't have a process and we don't have domain. We just have a validation API and a database. That's it. So we have just a few tests on that. We are not testing we are not writing sometimes even the services. We are calling repository from the controller. Why not? Because there's no logic. So the pyramid is inverted. We are focusing on API test, and this is the highest load. The most of the tests that we have is on API level. Similar thing is for the service that, hey, I'm writing the integration, I'm just writing the proxy. So whatever I receive API request that I receive, I'm just shooting to the external API. I'm just proxy. I don't have any logic. So from the Lego strategy, it modifies to something that, again, doesn't have a process, domain, and it doesn't have database even, because it's just proxying. Very similar to this thing. It had database without web clients. Here the situation is other way around. The thing is that, again, we have inverted pyramid and we can end up only with API tests. This guy, it is an example of messing up with microservices. We wrote so many microservices that we need to write one more to control all of them. So I don't have a domain inside, because those are specific microservices that are doing the job, but I'm orchestrating them. In this case, again, part of stuff will disappear in a moment. And what stays is the application services and process test. I have the process because I'm orchestrating it, but I don't have the domain logic because the lower layers have the domain. So they are doing important job. I'm just integrating them. So the high pressure will be on the process and on the process test. Not that much on API, not that much on validation or dependency. End-to-end, always. And the black box service. I call it black box service, not to call it legacy, because it's not just only legacy. Let's say that we are writing a component, a service, a microservice or big service, that we are just starting and we don't know what it's going to be. We know what API should do, but we do not in which way it's going to evolve. Because it's Genesis, something new. Or we're in a different case. So it's a commodity. So it was written long ago and we have APIs, but we don't know how it works inside. So for the legacy and for Genesis, we might end up only with API tests because the structure inside is either unknown or not possible to understand, or simply there is no structure inside, there's a mess inside, right? So the only secure thing that we can do is to write API tests, because the only observable behaviors we can find out on calling the API. So the pyramid is not only inverted, but it's not full, it's just floor 0 of pyramid. We might eventually end up having Lego tests, like validation, process, and domain, but it might be a future state. Yeah. And about the end-to-end test. I don't like them. Anyone found the difference? No one, there's no difference. Here, there's no difference as well. End-to-end tests have a big scopes. We are hiring testers, so they feel obliged to write something important. And they are taking a lot of responsibilities, which is pretty convenient for developers because they do not have this responsibility anymore. So the scope of end-to-end test is everything. Everything is yellow, right? It's what's happening inside the service. They are testing the internal logic. They are testing the communication and interaction of everything. So they have so many reasons to fail, and that's why they fail. So we have a tool to extract some of the responsibility from end-to-end test, and this is contract testing. The scope of contract testing is much different. It's only on the borders of the services, so controllers and infrastructure, input and output, they are not touching the inside logic. The inside of the service is being tested by functional test. This is the Lego strategy that I was showing. And we're testing the communication, right? Only the edge, plus whether we can talk with our counterparts. So here, the scope of end-to-end test is everything. It has to fail. There's no way it doesn't fail. The scope of contract test is just those two blocks. So excluding the logic, it's just infrastructure or adapters that are being in the scope of contract testing. This is the same, just zoomed in, because I wanted to fit those two images here. First is that a pact or contract between two services consists of, well, the request specification, so post on the price factor percentage with the body, and the response from the controller on this request should be that I return factors and the price. This is what proves that in the mesh architecture, we can somehow communicate. So it's the first step that this verification that I've shown previously is happening on the CI/CD. We do not have to deploy to environment to find out that our two systems are compatible, that their APIs are compatible. And in this mesh architecture that we are unable to tell who is using us, we might be unlucky ones who would be here in the XMesh tree architecture. I've even found a star. So this is truly XMesh tree. You might find out that we are here at the trunk. So everyone depends on us. And we are so afraid to touch our APIs because we don't know who are we gonna break with the change, right? So the risk is pretty big, and we don't know our consumers. We don't know what do they expect. Some time ago we've added a strange parameter like shoe size to the JSON that returns account balance because we've had Junior on board. and he added this parameter, and it's a pain in the neck, and we don't know whether we can remove it or not. I want to have an answer. If you try to remove it, you get red cross, and you just should roll back. And the red cross is not always the red cross, because we have parallel architectures, which means that we have 3 environments, and we might have a green version, which is the same version of the same service on every environment, be it dev, view, or prod. But let's say that second service didn't yet reach production with its green version. Not mentioning about this one, who is, I don't know what's happening, because there is a different contract version on every environment. So actually, I can securely deploy to development, because everyone is green here, but it turns out that I cannot deploy to what I call UAT, because this guy is blue. So I'm not compatible with this API. It's not just to deploy. I know we like emotions. We like feeling that fear when we are deploying, right? But I want to have an answer first, can I deploy? Then I want to record the deployment so that other can ask the same question, can they deploy? But can I deploy looks like this. So on Slack, we're asking whether, are you on prod already? You're doing it, I know. On Teams, on email, or we're checking the Epic status, whether the second team has already completed their implementation and whether we can securely deploy our part. Instead of having the computer say yes or no. Hopefully yes. So I want to have it automated, and this is what contract testing are for. It's not only for guaranteeing that your contract is in line, it's also to give you the security of deploying to the environment. It will write a bit more depending on how many consumers, how many providers you have. Right now here I have just one, but success is true, so my computer says yes, you can deploy, because the version of the contract on environment is the one that you expect. It was validated, and they have recorded their deployment, that they are there. You can securely deploy it. It's gonna work. They might have bugs inside, but it's the scope of their internal functional tests. But well, on the API, you will be able to query them. So the message is to move away from, just wrapping up, to move away from the structures that we have main with Java code, and we have more directories on tests than on Java code, and we have split whether this is Groovy, Java, Kotlin, whether this is test, integration test. So if I'm about to check whether my production class is tested, I need to search through several directories to find out where is it tested. Or just comment out the production code and find out which test is read. Hopefully some is. To move to something that we are just writing tests. And I don't want the framework to drive whether I'm writing integration test or unit test. I want to steer it differently. This is the test that is starting the framework, and this is very, very similar test. Those two lines are different. And this is testing the same, but it's not starting the framework, because I have my test base that is testing the logic. And here I have test base that is starting the framework, which has, all those Spring annotations. The case is that the framework starts every services, builds every services, starts the whole application. If I'm starting the logic test base, I need to build a vendor service as part of the services on my own, right? So I want them to be, I want to have the freedom to choose whether I start my framework or not. I'm starting the framework only if I'm testing things that framework is required. For my business process, that framework is not required. Okay, so I want to have the same structure in test code that I have in my production code. I want to have API REST or app, domain, and infrastructure. This is the test directory. I want to see that this system is domain heavy, right? I do have a lot of domain tests, so probably this is where the complexity here lies. It has the process, like 3 classes of process tests and several endpoints. So heaviness, the complexity lies in the domain. Yeah, and that's it. Thank you so much. Now is the time for questions as well.
Okay, questions?
Hi. Say you have 2 components that you need to test. One depends on the other. How do you decide between building an integration test that actually injects the actual object and a unit test with a mocked dependency?
I won't make to open it, a board from my training. I have it right there. The thing is whether the second component, my dependency, is private dependency or it is shared dependency. If this is the private dependency, so I'm the only user of it, then I'm using new always. If this is shared, so it is a kind of Xmas tree architecture, right? I have a component that is being used by everyone. I have to test this guy in isolation. But if it is a private dependency used only by me, as for now and in the foreseeable future, I'm using new because the fact that we are splitting code into classes is just for us. It's not, domain doesn't care about whether you have 5 classes or 2. It's just for us to improve the readability, right? In most of the cases. Right, so the fact that my method I'm extracting it to a separate class right now, it doesn't change the behavior, right? It's still the same, but I decided to move this long method or 3 methods into separate class. This still has a stable interface that I'm calling from the outside, and the fact that there is a new class somewhere there, it is private dependency. So I'm using new. I'm very often using new instead of mocking.
And if it's a shared dependency, but you need to cover a lot of kind of integration with it, do you cover all of this booting the Spring context app and all of that, or do you just do some critical cases and mock it for the rest?
I'm using new again. I'm testing it in isolation, right? First of all, this is shared, used by 10 other components, so I'm testing it in isolation to make sure that all edge cases are tested. But in most of the cases, my default mode, it's not that always, but my default mode, that I'm not injecting mock into all those 10 components that are using it. Because thanks to that, I don't have to mock it, right? It will be used. I don't have to mock it. I don't have to stub it. It will be used. I know that this is confirmed by other tests. So sometimes inserting new results in less code in the tests because I can avoid stubbing or mocking them there. And it's more output based, so black boxing.
Okay, thanks.
Okay, we have another question.
How would you recommend to solve the scenario that you can deploy the new version not only when another services are ready, but also when your service is finish all, let's say, important computation?
I'm not sure if I got the question.
Assume that you have a service which is responsible for going from one direction to another, and you can update it only when it's not it's not running. Let's say you have a train, you can deploy new thing onto the train, not during the ride, but when the train is finished the current route.
Okay, it's more on the deployment process, so no contract test, no functional test will solve this issue. It's more on the deployment process to make sure, to monitor the metrics that this system is not producing any more output, is not working anymore. I mean, it's not serving the API request, so the value dropped. So that the new instances that has started has already took all the traffic, and we can securely close the old instance because this is unused right now, right? So we need to make sure that this is unused first. Metrics and observability.
Okay, does anyone? Oh, Chris, you do?
Okay, great. So I noticed you are not a big fan of end-to-end test, but on the other hand, end-to-end could be a great source of, let's say, documentation of business processes. And what do you recommend in this situation? Maybe some BDD or different set of tests to actually provide this documentation and have a test of business processes?
We will always have end-to-end tests. I'm not a fan of them in the current setup as they are right now being done by companies. Because they have too many responsibilities right now. And this is why we are unable to focus them on what is important, which is documenting the business process, behavior, and core processes, right? Because testers or developers of end-to-end tests are actually focused on edge cases, on finding out regression, and so on. Instead of documenting the core processes, which is the goal of the end-to-end tests, right? But the name is doomed, I think. This is why I'm coming up with new names, not to be affected by old names. So yeah, coming back to the roots, yes, testing the behavior, testing the core processes, but only the things that we are unable to test before. The things that we are able to test before, like contracts or special characters in the first name, should be tested below, right? It's not the responsibility of developers of those tests.
Okay, so again, fail fast or shift left, yes?
Yeah.
Okay.
It's the same actually.
Yeah, and I didn't quite understand, like you call it Lego repo testing, and you call the real repository and a fake repository. But after some thoughts, it's like calling the real API and the fake API just to be sure that both of them are behaving the same. Is it the case?
Because if I'm not starting the framework in my tests, then I don't have a database in my tests, the real database in my tests, right? If my process is complex and storing to database is just one of the steps, then I want to have this complexity tested without starting the database, which is just a small step in that, right? So this is when I'm writing in memory repository, which is actually a hash map. Right, it's a hash map. So it has the same methods like save all, and so on. And this, in most of the cases, I'm just doing save or find. If I'm doing the more complex query and I was not starting the framework, then sometimes I make sure that my find is working correctly as my fake, right? I could, as an alternative, write one test that is extending framework test-based, which is starting the framework and making sure this way that this find is returning the correct value, right? So those are two options.
Okay, thank you.
Okay. Are there any questions? Any more? Okay, if not, big applause for Jacek. Thank you. There is a statue for him.